Hi, my name is Matthew Beeger.
Hi, I'm Nick Borg.
Hi, I'm Rumi Lagmani.
I'm Vincent Panaccio.
And I'm Andrea Kamovic, and today we're going to be going over our presentation for Project Nexus. A brief rundown of what our project is. Our Project Nexus is focused towards amputees and people with limb differences in order to help them while they drive their everyday automobiles.
Now, the problem currently is that vehicle modifications that are needed for individuals with limb differences are typically very expensive and not necessarily always accessible. Some insurances do cover these types of modifications to vehicles, but others do not. And in other countries around the world, these types of modifications are not regularly available for people. Additionally, for those who do have modified vehicles, license restrictions mean that the operator of the vehicle, the person with limb differences, are stuck to using that specific vehicle only. This causes problems when people are living in families with multiple individuals who are sharing cars. And these people with limb differences are not able to be as independent with their vehicle's usage as someone who's doesn't have limb differences. Our current solution is to have offer amputees the chance to drive again. Our solution is focused around individuals who are hand amputees or who are missing hands. Uh, our prosthetic is meant to specialize in functions for driving. The three main functions that we're focused on are steering, shifting gears, and changing lanes. These three are the most vital aspects of driving a vehicle today, and those are the ones that we have chosen to focus on to allow individuals to have the chance to drive again. Additionally, our prosthetic will be very cost efficient, meaning individuals who might not necessarily have access to healthcare will be able to purchase this without having too much of a financial burden compared to many other prosthetics currently on the market.
All right, so for a timeline of our project, the fall semester so far has mostly consisted of brainstorming, concept generation, concept evaluation, and concept selection. Now that we're at the end of the semester, we've begun 3D modeling of our concept, and we've begun generating and finalizing a parts list. We'll use this parts list during the winter intersession to order equipment, and then once that equipment arrives, we'll begin manufacturing our physical model, which we can then use to make a proof of concept. Then once the spring semester rolls around, we'll take our proof of concept, and then we'll iterate various prototypes, evaluating our design flaws at each iteration. Once we think we have a good prototype, we can test it with possible users and then analyze their feedback, which we'll then use to come up with our final design and our final prototype, which we can present in April.
So we went through a couple concepts trying to just figure out what our product is going to look like, or at least what we're going to initially design it as. So the concept we decided on that we're going to design towards emphasizes function over form. So it allows the operator, as Rumi had mentioned previously, to steer a vehicle, shift gears, and also to change lanes. Although pictured having five fingers here as what we were thinking of initially, it may not necessarily include five independent fingers, but will at least include something that's a claw style hand. So it's able to grip the hand with an independent thumb, and then we'll have some type of a grip where the other four fingers are, allowed to wrap your hand around a steering wheel to grab things. And then for the majority of the hand will be 3D printed for the parts, and then the final assembly of all this will be designed using SolidWorks.
All right, so like Nick just said, most of the manufacturing of the solid parts will be through 3D printing. This will allow us to keep the process cheap and easy. But for smaller parts like the parts utilized for our hinge joints, we'll still be using small nuts and bolts. Our electrical components, such as our myoelectric sensors and our actuators, they'll all be compatible with Arduino. This will allow us to keep our electrical and our software overview like very simple. And then if we need anything else, we always have the on-campus workspace and makerspace, which we can utilize to fabricate metal components if we need it for the prosthetic.
Now, for the electrical portion of our project, our main focus is utilizing servo motors. Now, what these servo motors are going to do is we're going to connect these servo motors to microfilament lining or fishing lining. And basically, these microfilament linings are going to be within the prosthetic hands in either each individual finger, or if we go with the claw grip or like a type of like three-finger grip, we could use like one selected for like three different fingers. Now, what these servo motors are going to do, are they're going to make an extend and retracting movement. So rotating will allow for the fingers to retract, while rotating counterclockwise will allow for these motors to extend. Now, in order to control these motors, we're going to use a myoelectric sensor. Now, what a myoelectric sensor does is it gets attached to your forearm right over here. And basically, it extends the electrical signals from your muscles into a mechanical function, allowing for the motors to rotate clockwise or counterclockwise. Now, to supply this electrical equipment, we're going to be utilizing a 7.2-volt battery, as it's very cost efficient and very long lasting. Also, we're going to make the battery easily accessible in order to interchange it. Say if maybe there's a fault in the battery and we could change it out quickly, or if when designing we need to draw more power, we could always put like a 9-volt battery in or something higher for the needs. Now, a basic circuit diagram is what we're going to be utilizing, that's shown on the right of the screen. However, anything is interchangeable, as anything that you do on the site and actually when putting the project together, anything could happen, new circuitry. But another thing we want to really focus on the circuitry is making sure that all jumper cables are soldered, as you don't want any components detaching, especially if you're driving a vehicle and a wire comes out and that's it. Yeah, an accident happens. This is the one thing that we don't want to happen.
So next we have like the software and hardware design. Basically, the system block diagram just shows how all of the hardware components talk to each other and how they're going to use the Arduino and the predefined functions to control the motors. So basically, the power supply is just that 7-volt battery, like Andrew mentioned, and then the inputs are either going to be user command, which is like any buttons that we have on the device to turn on and off or stuff like that. And then, like Andrew said, the myoelectric pressure sensor that'll be on your arm. And basically, like he said, how if you like open your hand like this or that, it'll sense here, and that'll be interpreted by the code written, and basically whatever you do will then be transferred over to the motors to either grip or let go of the vehicle of the wheel. So next is the software state diagram, and this basically just goes over all of the states that we plan on implementing with the hand. Basically, there's a steering mode, shifting mode, and blinker mode, and all of these just have different components on how much they grip, or how loose the grip is, or if they want to have one finger out for the blinker mode to change the blinkers, so you could change lanes. And another main component is the rotation feature of the wrist. So when it's gripping the wheel, it can rotate 360 degrees, so it's easy to drive. Or when it's shifting, it doesn't rotate, so it's easy to push forward and backwards. And finally, we have this little safety check loop, which basically just checks the sensors to see if anything's going wrong, or if it's feeling too much pressure so it doesn't break. And we're going to try and implement a like beeping feature to tell the user that something's going wrong and they should pull over or stop the vehicle. And thank you. That's our Project Nexus.